Hello students. So in the previous class we have discussed about how AC generator is going to operate. Similar to that AC generator, today in our class we are going to discuss about the DC generator. Okay. So at the end of the class we are going to differentiate between what is this AC generator as well as the DC generator. Here we are going to consider similar to that of AC generator, a armature, that is rectangular coil we are going to consider. This is the armature. So that is connected here. Similar to that connection. So that is, I am going to denote it as ABCD. So this armature is connected to the split rings. So whatever, like in the case of motor, what the thing we have discussed, similar to that, here we are considering in the case of DC generator, we are considering the split rings. That is S1 and S2 I am going to consider. That means one total ring we are going to divide, we are going to split into two parts. That are the split rings. That is commutator. We are going to split into two parts. So that split rings are connected to the brushes B1 and as well as this brush is called B1. This is called B2. This is connected here. You can see here this is connected to the galvanometer. You know. So what is the function of the galvanometer? Galvanometer will detect whether there is a presence of current in the circuit or not here. So this generator, DC generator, what is this DC generator means? This is direct current generator. This is similar to that of AC generator where it is using the principle of electromagnetic induction. Okay, electromagnetic induction, what we have discussed about the electromagnetic induction. So what is this electromagnetic induction means? When there is a change in flux, then there is a production of a current in the circuit, or current is induced in the circuit when there is a change in the magnetic flux here. So magnetic flux means when there is a change in magnetic lines of force here. So in the previous, like in the induction, what we have discussed, we have considered a magnet here and also a coil was there. When a magnet has come near to it or went away from it, that means when there is a change in magnetic field lines, then only there was a generation of current inside the coil. Here we are keeping a horseshoe magnet. This is the north pole of horseshoe magnet and this is the south pole of the horseshoe magnet. Here we are keeping a permanent magnet here, that is a horseshoe magnet. In this case, what happening here means, here we are not changing any of the magnets. In the previously we are changing the direction of magnet, that is coming into the coil or going out of the coil. That was we are doing here. Now in this case, that is in the DC generator, we can't keep or we can't change the direction of this magnet. Only we are changing here is they are changing this magnetic or you are changing this armature. When you are changing this armature is nothing but it is the coil. When you are changing the coil, then there is a production of current inside this circuit. So to change this, we are using a shaft or the shaft. So shaft is used. Shaft is nothing but where you are able to see in the case of generator. That means for products, for the running or for the generation of current, we are using this shaft like a hanger. So to rotate that coil, we are using this shaft here. So what is the main principle behind the DC generator means? It is converting the mechanical energy into the electrical energy. So converting mechanical energy to electrical energy is the main principle behind the DC generator. Now we have to see how the mechanical energy has been converting into the electrical energy. So see here, this is the shaft here. This shaft, we are going to rotate this shaft. That means I'll consider this shaft, I'm going to rotate in a clockwise direction. You know, for this to understand, we are going to use the Fleming's right hand rule. So first, before that, we have to know what is this Fleming's right hand rule. Let us do the revision here. So this is the right hand rule. Thumb and as well as first finger and the middle finger we are going to stretch as it is. They are all perpendicular to each other. This shows direction of force and or the direction of conductor or motion of conductor, in which direction you are going to change or in which direction you are going to apply the force. That is this thumb represent, and this represents the magnetic field and this represents the direction of current here. Since here we have known in which direction we are applying the conductor, that means in which direction you are applying the force here. And you know magnetic field will be from north to south. I can draw like this. From north to south the magnetic field lines will move. Now we have to see in which direction does the current flow in this circuit. We don't know in which direction current flow. Whenever there is a current has been flow means directly this galvanometer was started to show the deflection. Now we have to see in which direction does the current flow. First we will consider according to A and as well as B. Only in one single line we will consider how the current will flow here. Now I'll stretch my finger, 3 fingers as like this. So this shows the direction of motion, and this shows magnetic field, and this shows the direction of current here. Now when I start rotating in a clockwise direction, which comes to the upward. So when I start rotating this, for instance, so if I consider this as just an example, if I consider this as an armature here, so I am rotating clockwise. Clockwise means, for example, this is D here, this is the A position here. So when I rotate it clockwise means you can able to see that A position will comes to upward. This is the 3-dimensional picture. So this is A position will comes to up, B and A will come up, and you can able to see C and D will comes to the downwards position. So in this case, so A and B in upward means the rotation here, the motion of conductor will be upwards here, that is thumb represent motion of conductor, and you can see direction of magnetic field from north to south, and in which direction does the current is now flowing. So the current is flowing in A to B direction. So this is the direction of current here. Now let us come to the CD. In CD case, what is happening? In CD case, the motion of conductor was towards the downwards condition. So instead of this, I have to consider in this case. So in this case, the motion of conductor is downwards. This is the direction of magnetic field lines as it is from north to south. So in which direction current is flowing? Current is flowing towards down. Down means from C to D the current is flowing. Now we have known one direction of current here. That means current is flowing from here to here. And you know in this direction, in B and C way, there is no production of current here because the magnetic field and as well as current won't be in a parallel one, isn't it? If they are considering in BC1, no, current will not flow here because magnetic field and as well as current will be in not parallel to each other. You can see magnetic field lines will be in this direction, and if the current is also flowing in this direction means both will be parallel to each other. So there is no production of current when magnetic field lines are parallel to them. So that means this is the direction of current here. Now you can see this is the direction. So this is the direction, and it is coming down. It is coming down. This is, so you can able to see this is the positive side of the battery and this is the negative side of the battery. By this you are able to see which is the polarity. That means in which direction does the current is flowing here. Now this is about the half of the rotation. So when I reverse the direction here, that means whenever there is a like this from starting, if I have considered here means from A to B and CD it was there. Now I have rotated in clockwise so that AB comes upward and CD comes to downwards. So after half rotation you can able to see CD comes to this position. That means there is a change in their position and A and B will comes to here. Now I won't change the conductor here. That conductor will be in clockwise only. Now we have to see in which direction does the current flow here. This one I'll consider B1 itself and this to B2 brush itself. Now you can able to see this same principle you are going to use. So clockwise rotation, this one, magnetic field lines and direction of current. So here the current will flow from C to D, and as well as current from A to B will be flowing in this direction. That means this is the direction of current here, and this is the direction of the current in this case. So this is similar to that. This process will continue. First half, second half. Then after this rotation, once again when you rotate it, you will get to come to the same position. So this completes one complete cycle. That means one complete circle has completed. So this, because of that, there is a production of current in the circuit. So this is about the generator. Now, what are the things we have discussed? We have considered about the AC generator and we have discussed about the DC generator. Now comes, what is this AC generator and what is this DC generator? AC generator is nothing but it is called alternating current. AC is nothing but alternating current, and as well as DC is nothing but it is direct current. So what is this alternating current and direct current means? In detail, if you want to explain means, so alternating current means current will change, that is voltage in the circuit will change with respect to time. That means in the case of conductor, any of the conductor, if you have considered here, the flow of electrons inside the conductor will makes the charges or will makes the current to flow in the circuit. That means when an electron flows in a circuit, then there is a production of current in the circuit here. Now, what is this alternating current and what is this direct current means? In the case of alternating current, these electrons will change the direction accordance with the time. So, for example, for 1 second, the direction of current electrons will be in this position. Next half second, that means in next 1 second, the direction of electrons will be in this direction. That means there will be alternate. Alternate means once it will be moving in this direction, once it will be moving in this direction. So this type of current is called as alternating current. That means direction of electrons will change with respect to the time. But in the case of direct current, there is no change in electron direction. The direction of current will be constant. If it is moving in this direction means it will be in that direction itself. Okay, that is the major difference between the alternating current and as well as the direct current. So alternating current, we are going to represent it by a sine wave. How the alternating current will be? This is the graph of voltage versus time here. Just we have to understand what is this. So here this is the positive cycle, this is the negative cycle. So it is complete. Illiga A position, this is the B position anta artha madkondre. So from A to B, this is one complete cycle. One cycle means it has to complete. This is the positive side, that is half cycle. Idu half cycle. This is another half cycle. Downwards we are going to consider as negative only. So when the current or the voltage, when the cycle has been completed, this is the half of the cycle, this is another half of the cycle. So one complete cycle we are going to take it as frequency. Just we have to know what is this frequency, that's all. Frequency is nothing but here one complete cycle in a given time. In one time or 1 second, how much cycle it has completed, that we are going to represent as the frequency. So this may continue here. This is another cycle. This is another cycle. Like this, how many cycles? So frequency is nothing but number of cycles per second. We are going to take it as the frequency. So frequency in India, the frequency is for how many cycles? That is 50 hertz. So hertz is the unit for the frequency here. Now DC current, how the circuit will be? DC means the voltage remains constant with respect to the time. That means the constant voltage will be maintained. There won't be any positive ones, negative ones. No fluctuations will be there in the case of the DC current here. And also this AC current where we are going to use mostly in our home, that is electrical appliances what we are used in our home, that all will be from the AC only. And in the case of DC current is mainly used in the case of batteries. Batteries means phone batteries and flashlights. All these things, what is the battery we are going to use, that is direct current we are going to use. So this is the major, you have to know about what is this AC current and as well as the DC current. Okay, so I hope everyone have understood this. If any doubts is there, we will discuss in a live session. Thank you.